In this video, we want to determine which of these functions is a solution for the Laplace equation. What is Laplace equation? The two-dimensional Laplace equation is this: uxx plus uyy equals 0. Uxx means the second order partial derivative of u with respect to x plus second order partial derivative of u with respect to y. Sum of these two should be 0. If a function satisfies this equation, it means it is a solution for this differential equation. Let us start. First, we are going to find ux, the partial derivative of u with respect. Ux is 2x. Then uxx, the second order partial derivative, we take the derivative again with respect to x and it would be 2. Uy, the partial derivative of this expression with respect to y is simply 2y because the derivative of x to the 2 with respect to y is 0, only we have 2y. Then we are going to find the partial derivative of u with respect to y again. The partial derivative of u 2y with respect to y is 2. Now let's see, is this a solution or not? Uxx plus uyy should be 0. If it is 0, it's a solution. If this sum is 0, it is a solution, and otherwise it's not. 2 plus 2, this is 2, the other one is 2. 2 plus 2 is 4, and it's not equal to 0. So this function is not a solution to Laplace equation. Now we have this function. U is given ln of square root of x to the 2 plus y to the 2. First, we rewrite this function in the form of 1/2 ln of x to the 2 plus y to the 2. Why we can do this? A square root means power 1/2. We can bring the power down to the front. Remember, log functions, ln is a log function. When we have a log function, if we have a power here, we can bring it down to here. Why we do this here? Because if you want to find the partial derivative with respect to x or with respect to y in this form, it's a bit harder. This form is easier to find the partial derivative. So first we do a little simplification for the function, then we are going to find the partial derivatives. Ux, the partial derivative of u with respect to x. We keep the 1/2 as the coefficient. Remember, the derivative of ln of an expression is 1 over that expression. So the derivative of ln of x to the 2 plus y to the 2 would be 1 over x2 plus y to the 2. But because of the chain rule, always we multiply by the derivative of the inside. What is the derivative of the inside? What is the derivative of the bracket? The derivative of x to the 2 is 2x and the derivative of y to the 2 is 0, because now our focus is on x. If we simplify this, we can rewrite this in the form of x over x2 plus y2. The 2 from numerator with the 2 from denominator cancels. X multiplies in numerator, so we have x over x2 plus y2. Now we want to find uxx, the second order partial derivative. For finding uxx, we have to take the derivative of this expression with respect to x with the quotient rule. The derivative of the top, based on the quotient rule, first we have to take the derivative of the numerator. The derivative of numerator with respect to x is 1 times by x2 plus y2 minus, keep x here. Right, the numerator multiplied by derivative of the denominator. The derivative of the denominator is 2x. With respect to x, the derivative of y to the 2 is 0. So the derivative of all of the denominator is only 2x. All over x to the 2 plus y to the 2 all to the 2. We can simplify this in the form of numerator, if you pay attention, is x to the 2 plus y to the 2 minus 2x to the 2. So x2 plus y2 minus 2x2. So x2 plus y2 minus 2x2, 2x2 over x2 plus y2 all to the 2. This would be y squared minus x squared over x2 plus y2 to the 2. Second order partial derivative of this given function with respect to x is y2 minus x2 over x2 plus y2 to the 2. Because of symmetry that we have in this function with respect to variables x and y, can you guess that without calculation what would be uyy if we calculate? Uxx is y2 minus x2. So uyy would be x2 minus y2. You can check this by finding this from derivative formulas, but we are not going to waste our time for this. You can see this easily, and the denominator would be the same. Now that we have uxx and uyy, let's see what is the sum of uxx plus uyy. If we add these to each other, the denominator of these two fractions that here we have, let me name this 1 and let me name this equation number 2. If we add equation number 1 to equation number 2, the denominators are the same, so we can add the numerators to each other. Now, Look at the numerators. They are negative of each other. We have y2, we have negative of y2 in the other one. We have a negative x2 in the equation number 1, in the equation number 2 we have positive x to the 2. So if we add these to each other, the numerator would be 0, and 0 over that expression is 0. So this means that this function is a solution, to the Laplace equation. What about this function? U is given tangent inverse of x over y. Let me remind you, what is the derivative of tangent inverse? The derivative of tangent inverse of an expression, whatever it is, its derivative is simply 1 over 1 plus that expression to the 2. So if that expression is x, 1 over 1 plus x to the 2. But if that expression is something other than x, at the end, because of the chain rule, you have to multiply by the derivative of that expression. Let us start. We want to find the derivative of tangent inverse of x over y with respect to x. Its derivative would be 1 over 1 plus x over y to the 2. X over y to the 2 can be written as x2 over y2. xy all to the 2. X over y all to the 2 would be x2 over y2. Times by derivative of this. Derivative of x over y. Times by derivative of this. For finding derivative of x over y, attention with respect to x. Y is a number like x over 2. What is the derivative of x over 2? 1 over 2. What is the derivative of x over 5? 1 over 5. So what is the derivative of x over y with respect to x? Just 1 over y. And this is the derivative of the inside. So why we multiply by that? Because of the chain rule. Let's simplify this answer, because we don't like to have an answer like this. For simplifying this expression, you can multiply numerator by numerator, denominator by denominator, then do a little calculation after. Multiply numerator by numerator, 1. If you multiply this y in this term and in this term, y times 1 is y. Y times x2 over y2 would be x2y over y2, 1y with y1, 1y in the denominator cancels, so we have x2 over only 1y. Now to simplify this answer a little more, you can leave it like that, but you want to take the derivative of this expression with respect to x again, so it's better to simplify it first. Don't leave it like that. To simplify this, the normal way is to put a denominator 1 here, do a common denominator between these two, and then do this division. The other way that it's maybe a little better is to multiply numerator and denominator by y. Why we do this? Why we multiply numerator and denominator by y? Because the reason that I prefer to multiply the denominator by y is that I want to multiply this y in these terms to get rid of this y in the denominator, because I don't like to have a fraction in the denominator, in this big denominator. So I am going to multiply numerator and denominator by a y to get rid of that extra y that we have in that fraction in the denominator. Then we have y times y times 1 in the numerator is y. If we multiply y in the denominator, it would be y2 plus x2. When we multiply this in this term, this and this cancels. So this is the answer for the first order partial derivative of u with respect to x. Now from this answer, we have to find uxx. For that, we can use quotient rule. Based on the quotient rule, first we take derivative of numerator. Derivative of numerator with respect to x is 0. 0 times the denominator is 0 minus. Leave the y in the top. Multiply by derivative of denominator with respect to x. Derivative of denominator with respect to x is only 2x over denominator to the 2. So the answer is negative 2xy over x2 plus y2 to the 2. Now let's find the partial derivative of this given function with respect to y. For finding the partial derivative of u with respect to y, again we use the formula that we know for tangent inverse. The derivative of tangent inverse is 1 over 1 plus that expression to the 2x2 over y2 times by derivative of inside. For finding the derivative of x over y with respect to y, either you can use quotient rule, or you can say this is basically x times y to the negative 1. Then based on the power rule, we bring the negative down to the front. It would be negative 1xy to the negative 2. And this is basically negative x over y to the 2. If you use quotient rule to find this derivative, also you are going to get this answer. So the answer is negative x over y to the 2. Let me erase here, so we have a space for other calculations. Multiply numerator by numerator, denominator by denominator, and the answer would be negative x. If you multiply y to the 2 in the denominator, y2 times 1 is y2. y2 times x2 over y2 would be x2. Now from this we are going to find uyy. We use quotient. Based on the quotient rule, derivative of the top is with respect to y. Attention, we are taking derivative of uy with respect to y to find uyy. So it would be 0. Derivative of the top times bottom would be 0. Minus, we don't need really to write that 0. Minus, write the numerator times by derivative of the denominator. What is the derivative of denominator with respect to y? It would be 2y. All over y2 or plus x2 or x2 plus y2. The order really doesn't matter. To the 2. So the answer would be 2xy over x2 plus y2 to the 2. Now attention. If we add this to this, what is the sum? uxx plus uyy would be 0 because the denominators is the same. So we add numerators, 2xy minus 2xy is 0. So this is also a solution of Laplace equation. Now look at this function. U is given sine x cosine hyperbolic of y plus cosine x sine hyperbolic of y. Usually students forget derivatives of hyperbolic functions, or some of them even do not know what is hyperbolic function. But it's not a big deal here. Just it's good to know that derivative of sine hyperbolic of x is cosine hyperbolic, and derivative of cosine hyperbolic of x is sine hyperbolic of x. This is the only thing that here we need to know, because we want to find partial derivatives. We don't want to learn about hyperbolic functions. So let us start. First we are going to find ux, partial derivative of u with respect to x. In both of these terms, as you can see, we have x. The derivative of the first term with respect to x would be cosine x, cosine hyperbolic y. The derivative of cosine x would be negative sine x times by sine hyperbolic y. And from that we have to take derivative with respect to x again, because we want to find the second order partial derivative of u with respect to x. The derivative of cosine would be negative sine. Keep the cosine hyperbolic because it plays the role of a coefficient for that term. Derivative of negative sine is negative, plus times negative is negative. Derivative of negative sine x is negative cosine x, and we keep the sine hyperbolic here. What is partial derivative of u with respect to y? Sine x times sine hyperbolic y. Cosine x times cosine hyperbolic y. Attention, this time we are taking derivative with respect to y, so we take derivative of this term and this term. These two other terms play the role of a coefficient. You don't need to use product rule here, because our focus when we take derivative with respect to y is only on the y, and everything other than y is a coefficient, is a constant. Now we have to find uyy. We have to take derivative with respect to y again. It would be sine x cosine hyperbolic, cosine x sine hyperbolic. Derivative of cosine is cosine hyperbolic is sine hyperbolic. Derivative of sine hyperbolic is cosine hyperbolic, and we don't have any negative for this. Now look at relation 1 and relation 2. If you add these to each other, if you add relation 1 to relation 2, you can simply see that uxx plus uyy equals 0. Because this term is negative of this term, and this term is negative of this term, so the sum of them would be 0. So this function is also a solution to the Laplace equation. What was Laplace equation? This is the Laplace equation. This function is a solution for this equation. I hope you like this video. If you like this video, please subscribe in my channel, and see you in the next videos.